Alright, hello once again, Jeff Scott of Rankin Technical College. I've been going through a series of video presentations based on the Murox JavaScript and jQuery 3rd edition textbook that we use for our AWD Application and Web Development 1000 Web Development Technologies class at Rankin. In the classroom, we went over sections 1 of the book and 2, which are the first 12 chapters. Now we're in the advanced stuff, which we don't have time to cover in the class, but I thought for completeness sake I would go over it anyway. We are in the last chapter of the book, and you'll notice this is how to use immediately invoked function expressions. They're also called IIFEs. IIFEs. As it says, they're frequently used in JavaScript applications. Normally, as the author says, you first define a function and then you invoke it. And we looked at examples of that throughout the book. However, when you use an IIFE, you define and invoke a function expression in one step. So, the author says this is the way we typically do it. And you'll notice we've got a function called say hello. So this is the function, and this is the function invocation. But in here we put the parentheses on the end, so we not only write the function, but we immediately call it right there. Alright, there's two ways of doing this. Okay, two ways to code the parentheses right here, and the author does mention it here on the previous page. The author says you can code the parentheses of an IIFE in two ways. You'll see both coding styles in books and online examples. Although some programmers have opinions on both, it's like anything else. If you end up maintaining someone else's code, they might do it one way, they might do it the other way, they may do it both ways. This book uses the first style. It says here you should know that an IIFE comes after the start of a line of code. If an IIFE comes after the start of a line of code, the JavaScript engine doesn't require outside parentheses, but it's still considered a good idea to use them. IIFEs can be used to keep variables and functions out of global scope and keep variables and functions from conflicting with one another when they have the same name. And they will show examples of that as we go on. Like any other function, you can code a parameter list for a function that will be immediately invoked. Benefits of using IIFEs is shown on the middle here of the page. Helps you keep variables and functions out of scope, out of global scope. It helps with name conflicts. Notice we got a var today here and a var today here. So an IIFE or an immediately invoked function expression is a function that is defined and invoked at this all at once. You define it, boom, you invoke it right away. An IIFE should always be coded within parentheses so the JavaScript engine as well as other programmers know that it's an IIFE. Like a regular expression call, an IIFE ends with opening and closing parentheses, so you can't have arguments in there. We'll see that in the next page. If no reference to the IIFE remains when it's done running, its scope is destroyed, even if the function or file that contains it is still in scope. So it says how to use an IIFE to solve the closure loop problem. If you're working with closures in a loop, you could have a problem if you don't understand the 2 points at the start of the next figure. First, an inner function has access to the values in its scope chain by reference, meaning that if the value of the outer variable changes, then the value will change inside the inner function as well. Second, the values of the variables in a function are determined when the function is invoked, not when it's defined. All right. Whoops. So it just repeated that here. So notice in the comment that they have here, it says this is a closure, so value of I is by reference and can change. When the function is invoked, the value of I will be its last value. It's very important that you understand the concepts of passing by value and passing by reference. All right, and what I mean by that is, again, going back to the example that we looked at earlier here, let me stop this. That if I do something like this, let's suppose I did this. I called display and I passed in X and Y. All right, it's going to print out exactly what we said here, the value of this, the value of this. But now suppose I did this. All right, and this is kind of scary. And what I'm telling you, I believe is correct. I'd have to write a program to be sure, but it's worth showing you. I'm going to grab these lines of code here, and I'm going to copy them to the clipboard. And I'm going to come down here. In fact, let me add. So I'm going to come down here and I'm going to say this. I'm going to come in here, and in here I'm going to change the value of X. All right. And now sum has not changed because I have not changed the value of sum. But if I do come in here and I say this, sum equals X plus Y, well, the first time through there that said the value of X is 31. That's what we got passed in. Then the value of Y is 17 and the value of sum. But now we've changed it. So what should print the second time here is the value of X is 11. The value of Y is 11. The value of sum is 22. But this X and Y that we've changed here and here, those, that X and that Y, those are copies because we passed the X and we passed the Y. We passed copies of them. If I come back in here and I put in this, I believe what's going to print here, and again, you'd have to run this to check it, would be, oops, try that again. The value of X is 31, its original value. The value of Y is 17. When I say original value, that's the value it was set inside of the function to which it was defined. But I believe that the value of sum is still going to be 22. So you can get and go in and do some kind of screwy things. And that's not just in this language. When you pass by value, or also known as pass by copy, this line right here is as though we said in here 31, 17. We're passing a copy of what's held in here. All right? Some languages like Java, for example, that's basically the only way that they allow you to do it. With a simple or primitive variable is to pass by copy. Next semester in the C# class, and I don't want to be too confusing right now, but you can put the word ref in there, which means pass the address. So any change we would make in here would be a permanent change. All right. Sorry for that going off on a tangent there. All right, that's all I'm going to say about these, except I'll give you a couple more URLs here because I'm not being super complete here. This is IIFEs as they are mentioned, again, from the Mozilla Developer Network. I can't say enough about the Mozilla Development Network, developer.mozilla.org. All right, they just have a lot of really good stuff in it. Some people have told me, some students have told me, you know, I don't like it because it's dry. Well, a lot of the writing that you'll go through in the information technology field will seem a bit dry. All right. So the other thing that I saved for you here, and I probably already removed it, but no, I didn't. It's from a drip of JavaScript, an introduction to IFEs, immediately invoked function expressions. And it's just filled with examples. I liked it when I saw it. All right. But like I said, I'm not going to go through any more. That's it for IIFEs. All right, and I am at 10 minutes, so I think I will continue on here and go into how to work with the module pattern. We're somewhere around halfway into this, chapter. So, it says many developers and third-party libraries use the module pattern, which uses an IFI to create a single instance of an object that has private state. In the topics that follow, you'll learn how to use this pattern in your own code. So they first talk about a singleton, and they mention that a singleton is a pattern in which you have only one instance of an object. The easiest way to create a singleton is with an object literal. And they will talk about this in here. So here's an example. The task list object that we used in the last chapter was a single object that's in charge of all the operations of working with tasks. It's created when the file that contains it loads, and there's no way to create another one. The problem with using object literals is that sometimes they can't. I shouldn't say sometimes. They can't have private state. You can overcome this problem by using a function to create a closure with private state, but this means you can create multiple instances of the object. So instead of that, you've got the module pattern, which allows you to combine the benefits of object literals with those of closures. It uses an IIFE that we just finished talking about to create a single instance of the object that's returned by the function that creates the closure. This is referred to as a module. That way you get a single instance of an object, but the object has private state. And that's what this slideshow object is designed to show you. It's been rewritten to use an IFI. Now there's another example down here. This module pattern oftentimes is used in conjunction with namespaces. What a namespace is, you'll learn much more about it next semester when we talk about using, and we actually talk about namespaces in C#. But it allows you to keep your objects out of the global namespace. And the reason that's important is that it prevents what are called collisions. So let's say that me and Mary are working on the same project. All right, but we're doing different parts of the same project. And we have totally different functions, but we use the same name to refer to a variable that's in the function. We could have possibly collisions when our code gets intertwined with each other. So a namespace lets you keep your objects out of the global namespace, and it allows you to avoid collisions. To create a namespace, you assign an object literal to a variable. Then you add the IFI to the object. All right. Now, they do mention on the bottom of page 560, the author says the module pattern is also easy to augment, so you can split code for your object into multiple files. Well, the author doesn't exactly say it here, but quite often in this book, the author will say things like, and this is an easy topic. None of this stuff is easy. All right. So they show you next how to actually augment a module and use these accessor properties. And they mention on the bottom of page 563 here where we are, to augment a variable, you use an IFI and you import the module to be augmented by passing it as an argument when the IFI is invoked. One drawback from an example like this, or the slideshow example that's shown, is that the slideshow object had to make the private speed variable public for it to be changed. To address this drawback, you can use the second parameter of the create to create accessor properties, which use getter and setter functions to retrieve and set the value of a private variable. You'll learn more about getters and setters in the Java class. All right. So the next thing they do here is they go and update the slideshow that we worked on earlier in the chapter. And the first thing that it does here is that it uses a module pattern to create the slideshow object. Second, it uses accessor properties for the slideshow speed and for an array that holds the images. And you may be getting to the point too where you're like, okay, there's just so much information. Why do we need to use all of this? The answer is technically you don't. But when you're working, if your job is to be a web developer, quite often what that's going to entail is that the website be as optimal as possible, that people are able to click through it at the speed they want to click through it, make it go faster, make it go slower, etc. I know, as an example, I take courses online quite often from a thing called Udemy, udemy.com. It's a great site. There's a lot of really good information out there. But what I want to get across to you is sometimes I will take a class where the instructor talks like this. So what I can do is I can speed it up. All right? So it'll sound more like, sometimes I take a class where the instructor speaks like this, or I can even speed it up more than that. In many of the same ways, when users begin, or when they go to a website, many of them want to get in and get out. So we're using things like ifs, etc., closures, the module pattern, to try to expedite the user's experience. So this slideshow button adds a button that changes the speed and a button that displays a list of images. The application uses the module pattern for the slideshow object. This lets the application use a single object with private state, and it allows the code to be split among multiple files. The application also uses accessor properties to access the slideshow's private state. So the library is shown on page 567. It creates the My App namespace, and then it adds the slideshow object to it using an IFI. The IFI is invoked as soon as the file loads, meaning that a single instance of the slideshow object will be created. The private speed and img.cache variables are accessible only through the accessor properties. This protects the internal functionality of the slideshow object while still allowing partial public access. Next, they have the Enhancements Library on page 569. And the author says here that the Slideshow Enhancements Library adds two new methods to the existing slideshow object. It does this by using an IFI and importing the slideshow object. First, there's change speed, which changes the speed of the slideshow. Then there's display slides, which displays a comma-separated list of the image files of the slideshow. This provides an array of image objects. The main file uses an alias to work with the slideshow object in the My App namespace. All right. Before we go on and talk about how to use the module pattern to create jQuery plugins, which basically is the rest of this chapter, the last, 15 or so pages, let's stop right here and we'll finish that as the last part of our lecture.